Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 865, which was written for Division 2. And it was written for Division 1 as well, but we are going to discuss the three problems of Division 2. So I was able to solve the first three problems during the contest, and I didn't solve the fourth problem, and it had a very few submissions, around 200 by the end of the contest. And I believe like today's problem were more on the constructive side problems, and there was not much difficulty difference in terms of B and C, but there was a huge gap between C and D. So that is why like there were a very few submissions on problem D. So without wasting any more time, let us quickly start with the first problem. So the first problem says that like there are two people, and let's just simplify the problem. It says that we are currently at index 0, 0. This is a cell, and we have to go to a cell A, B, right? So this is what we want to do, and we can use at most two jumps, and we can make a jump to a point x, y only when if we connect the current point to the point x, y, that particular line should not have any of those points, any of those integer points. So let me just show you with a diagram, and it will be much like easier for you to understand. So for example, this is a grid, and the grid will be something like this, right? So let us say this is index 0, this is index 1, this is index 2, this is index 3. So like first of all, the problem statement says that the value of a comma b will always be greater than or equal to 1. So obviously like this will be the search area. So you will never be able, you should never search in the 0th index. You will always be searching from 1th index. So this is 0, 1, 2, 3, 4, 5, right? You will be lying somewhere in this particular area. So for example, if I want to go to this particular cell, right, from 0, 0, then there is a straight line like this, and there is an integer point, right? There is a point 1, 1 which lies on this particular line. So if there is a move like this, you cannot make this move. If you are connecting 2 points, if you're going from point A to point B, there should be no integer cells inside it, like on this particular line. So this is our condition. Now, how do we know whether there will exist any integer points or not? So for example, if you have any line, so for this particular thing, you need a little bit of geometry knowledge or mathematics knowledge. So general line equation is y minus y1 is equals to mx minus x1, right? This is an equation of a line. Now what happens is y1 and x1 here are 0. So what we have is y is equals to mx and m will be equals to y by x. So this is the slope of the line. Yeah, y by x is equals to m. So this is the slope of the line. So what information do we get from this particular value? It means any integers x and y that satisfy this particular condition will lie on this particular line, right? So for example, if you have 4 and 2, right, this is the current value of y and x. So y is 4 and x is 2, and that is equals to m. So that means you would still be able to satisfy this particular condition with y is equals to 2 and x is equals to 1, right? There will be smaller values of y and x that satisfy this particular condition, and hence you cannot make a jump from 0, 0 to 2, 4, right? You cannot make this jump because there will always exist some simpler values or smaller values of y and x such that they also satisfy the same condition. Now there is very interesting thing that you must have observed, and that is you see that the GCD of these two values is not equal to 1, right? Whenever the GCD of these two values is not equal to 1, that means there will exist some simpler values that satisfy the same equation, right? Once we have some values like y is equals to 5 and x is equals to 3 or x is equals to 2, you will observe that this is the only value that satisfies this condition. There might be some bigger values. For example, if like this is 0, 0, the first point that is satisfying this condition is 2, 5, and the next point that will satisfy this condition will be 4, 10, right? There might exist some bigger values, but this is the smaller value, and there will be no other value between 0, 0 and 2, 5. So we can make this jump, right? So the very important observation is whenever the GCD of x, y is equals to 1, or rather if I write it in a more general format, if the GCD of x2 minus x1 comma y2 minus y1 is 1. That means we can make this jump, right? So how do we make this always possible? Now this is the very interesting part that you will observe. So how do we use this particular information in our question? So for example, if you want to go to point A comma B, right? Now you are currently at x1 is equals to 0 and y1 is equals to 0. Now let us try to make a jump at x2 is equals to 1 and y2 is equals to b plus 1, right? So if I have these values, then the GCD will be x2 currently is 1 minus 0, comma y2 is b plus 1 minus 0, right? So the GCD of 1 comma b plus 1 will always be equals to 1. That means I can safely jump from index 0 comma 0 to 1 comma b plus 1. Now from 1 comma b plus 1 I want to go to a, right? So I have to go to GCD of a minus 1 comma b minus b plus 1, or let me take it as b plus 1 comma b minus b, right? You can take any of the coordinates. So again the GCD will be GCD of, there will be some value here a minus 1 and 1 will be left here. Again the GCD would be 1. So this means I can safely make a jump from 1 comma b plus 1, or you can also take it as 1 comma b minus 1. It's your wish. Whichever value you take, both will work. So we can make a jump from 1 comma b minus 1 to a comma b, right, in one move. So this is exactly how you can make a jump in two moves. And if initially the GCD of x and y was 1 itself, then you would have directly jumped from 0 comma 0 to x comma y, right? This is also a valid solution, right? So let me just show you the code for it now. What I've done is I've taken two integers x and y and I just check whether the GCD is 1. So I can just print the final answer in one move and I can directly jump to x comma y. Otherwise, I can print the final answer in two moves, and what I do is I first jump to 1 comma y minus 1 and then from there I jump to x comma y, right? So this is how we can make the jump in two moves. And you see, like when I'm going from point A to point B, the GCD of x2 minus x1 comma y2 minus y1 is always equals to 1, which makes sure that this is the first point on the straight line that I am traveling, which occurs as an integer, right? And all the other integer points will occur only after it. So there is no point between the current point and the next point, right? So let me just jump to the second question now. So the second question is grid reconstruction, and it says that we have to form a grid of size 2 comma n, and we have to use integers from 1 to 2n, right? And there is like some way of traveling through the grid, and we have to make sure that the minimum cost over all paths is maximized, right? So this is what we have to do. So this question is like just a bit of observation. You can also if you try to observe the test cases carefully, you will be able to form the answer on your own. So let me just share with you what is the observation from the test cases. So if I'll just take this particular thing and we'll discuss this. So if I have these test cases, so let us take the second test case where n is equals to 4, right? So if I have a grid like this, right, this is my grid. You would always observe that the first integer, since we are taking alternating sums, then the first integer will be positive, the second integer will be negative, then again positive, then negative, and this will again be positive. So you see the first and the last integers are always positive. And again in this manner, if I go down, this is negative, this is positive, this is negative, and this is again positive, right? So no matter which way I take, the first and the last integers are always positive, right? This is my very first observation. So what happens is, and you might be wondering what happens if we extend it one more time. Then that is not possible, because the question mentions that n is an even integer, right? So if it is an even integer, this is the only case that can be formed, that the first and the last integers are positive. So if they're positive and I want to maximize the minimum sum, it is very intuitive that I can place the maximum and the second maximum number like this, right? So I just place the greatest two numbers at some places which I know will definitely be present in my answer and will definitely give a positive contribution, because the starting cell and the ending cell are always included in my answer and they are giving a positive contribution. right? So I just include the greatest two numbers here, right? So now what happens is, there are two ways to go from the starting set. Both of those ways will lead to a negative value, right? Since I want to maximize my answer, what I can just do is I can place some small value here and some small value here, right? So no matter which path I take, they will always like subtract some small value from my answer, right? So this is my intuition. Now the next value is positive in both of those cases. So here we have a positive number and here we again have a positive number. So again, I would want to take the maximum value I can take so that it is included in my answer. So if I first following this particular path on the right, since I have subtracted a greater number here, I should also add a greater number in this particular path. Similarly, I have subtracted a smaller number here, I can subtract a smaller number from here. I can add a smaller number to here, such that the overall sum is maintained, right? Again, I have two negative places. Again, I would want to like subtract a smaller value. So again, I start from the smaller end and I like add my integers like this. So this is the exact same thing that you would do on a bigger test case as well. So for example, let us take n is equals to 6. So this is the thing that you could have observed from the sampler test cases, and it is not very difficult to form a pattern like this. So here we have 4 cells and I just add one more, and this is 6 cells, right? So this is for n is equals to 6. So again, I place the greatest two integers in these two positions, 11 and 12 and 11. Now I place the smallest two numbers. Now I place the greatest two numbers that I have, and that would be 10 and 9. And then I place the smallest two numbers that I have, that would be 4 and 3. Then I place the greatest two numbers that I have, that would be 8 and 7. And then I place the smallest two numbers that I have, that is 6 and 5. Right? So this is the only thing that you have to do, and this will lead to a correct answer. So this was the solution for this particular problem. And if you carefully see, then you could have also inverted the problem. Like you could take 12 in the lower end and 11 at the upper end, and then you will have to invert all the values accordingly. You see, 5 is present in the lower cell here, and 5 is present in the upper cell here, and 6 is present in the upper cell here, so 6 is present in the lower cell here. So this is exactly the same solution, it's just that it is inverted, right? So let me just show you the code for you for this problem now. So what I've done is I've taken an integer n and I've created my answer array of size 2 cross n. So I initialize my high value or the highest value as 2n, and I initialize my lower value as 1. So I just set the 0, 0 as highest value, and I just post decrement the value of h. Similarly, I set the last value as highest value, and I just post decrement the value of h again. So I just traverse through the loop, and if I is odd, I mark the values as the highest values, and again I'm just doing the same thing, and I'm just post decrementing the value of h. And if the value of I is even, I just add the lower two values. So this odd and even thing is something that you must observe from here, since you see that this is 0, this is 1. So whenever we are at odd position, we are taking the lower two values, right? So but I have the way I have done the indexing is a bit different. So I am considering I and I plus 1. So for example, this particular position is even and this particular position is odd. So I am considering, if I want to place the maximum value, I am taking an odd value and I am choosing I and I plus 1 to add the answer. So whenever I is odd, I am taking the highest two values, so that I can place the one value here at the lower position and place the higher value at the next position. And if n is even, like in this case n is 2, I can place the lower value here and the next lower value at the next I plus 1 at position. So this is exactly what I am doing, and you can just like this particular part, you can implement it in your own way. All of the implementations is correct. Just make sure that you are putting the values at the right place. So after we have done this, I can just directly print the answer array and both of the lines in different lines. So this would be the solution of the second problem. Now let us quickly jump to the third problem. So this particular problem is ion and array sorting. So in this particular problem, we have been given an array, and in each operation we can choose any two adjacent elements and either increase both of them by 1 or decrease both of them by 1, right? So this is the only operation we can make, and we can make infinitely many number of operations. We just have to make sure that the final array is in non-decreasing order. So we just have to tell whether this thing is possible or not, whether we can make the array in non-decreasing order or not. So let me just show you with some sample test cases. So before directly talking about the sample test cases, I would like to share some important observation with you all. So let's say any element at index I, and we have an element and at index I plus 1, right? So we have these two elements. The array will be non-decreasing order when the I plus 1th element is smaller than the ith element, right? Ideally it should be greater than or equal to, but we have a case when it is smaller than the ith element. So there are two ways to correct this particular thing. What we can do is we can take a of I plus 1 and add 1 to it, or add the difference amount to it, such that it becomes equals to ai, right? We have to add some dx such that it becomes equals to ai, and we will have to do the same thing to a of I plus 2 and add some value dx to it. So this is case 1, right? This is one way of solving this particular problem and resolving this inequality. Now the second case can be, now we have another way of solving the same problem. What we can do is we can take a of I and subtract dx from it such that it becomes equals to a of I plus 1. Again, I'll have to do the same thing. We'll a of I minus 1 and subtract dx from it such that the value ai becomes equals to a of I plus 1, right? So this is the only thing that we have to do. So how do we make sure that we are performing the operations in some order such that we can form our final answer? You would always observe that we have these two possible cases only when we have some value to the left of ai and some value to the right of ai plus 1, right? If this is ai and this is ai plus 1, then we can perform these two operations only when we have some value here and we have some value here. If one of them is missing, then we only have the other possibility remaining, right? So we must have there will be some cases, for example in the case of corner elements, that is the first element here and there will be some array elements, and the last element here will only have one possibility out of these two possibilities, right? So an ideal way to solve this problem is to just try to fix the array starting in one direction by doing brute force, right? So we will be trying to solve this particular equation with some brute force method. So what we do is we just start from this particular position, right? The first index. So this is the first index. Now I just check if a of I is less than a of I minus 1, right? If this satisfies this particular inequality, that means that these two positions are not in some correct order. So I would try to fix these two positions, right? Again, I just move one place forward. After I have fixed these two positions, after I have fixed these two, by updating the values of these two indexes, I just move one place forward and I check the same inequality between these two positions. If the position is the inequality is again this particular inequality is satisfied, that means again our array is not in order. I will try to fix these two indexes, right? And I will keep on fixing these indexes, and the last inequality that I can satisfy is between these two elements. So if these two elements are not in correct order, then I will try to increase these two elements, right? But what happens if there is an inequality between these two elements? There are no elements further, so I cannot increase them. So instead, what I have to do is, since I have increased all the all the elements in this particular order, then definitely all the inequalities starting from here to here have been corrected. Now the only inequality that is remaining is this one, right? Now if I want to fix this one, then what I have to do is I'll have to do the same thing just in reverse order. So if I want to fix the inequality between these two, I'll try to subtract something from these two values, right? Again, if I have subtracted something, then I'll have to check whether the inequality or the thing that I corrected previously has been disturbed or not. If it has been not disturbed, then I can leave it as it is. If there was some changes and it has been disturbed, that means I need to correct it again. So this will be like a ladder effect. So I satisfy the inequality here, but it disturbs the previous inequality. So I again try to satisfy, and I just keep on passing it. So if after passing all these values, and after satisfying all these inequalities in this particular fashion, at the end I'll get an array, right? So if that particular array is in sorted order, if the final array is sorted, that means I found my answer. Otherwise answer will never exist. Why? because at the end, if these two inequalities are not satisfied, like if this is the condition as a is 0, a of 0 is, if a of 0 is greater than a of 1, right? At the end, if this condition occurs, that means to correct this particular condition, you will have to again take a forward loop, and you will be stuck in an infinite loop for this particular thing, right? If you try to correct it in the forward loop now, you will be passing the same thing to the last element. Again, the last element and the second last element will not satisfy the correct ordering. Again, you go backwards, right? So this will create an infinite loop. So what we do is we try to do it once in the forward direction, then we try to do it once in the backward direction. If the final array is sorted, then the answer is yes. So if it is sorted, the answer is yes. Otherwise, the answer will be no. Right. So this would be the solution of this particular problem. Now let us have a look at the code now. So what I've done is I've taken an integer n and I've just created a vector and taken input in. So I just start from index 1 till less than n minus 1 and I just check if v of I is less than v of I minus 1. Now I create the value dx that I need to update. So I just increment the value of v of I and v of I plus 1 by dx. Again, when I've done it in the increasing order, I just do it in the reverse loop as well. I start from n minus 2 till it is greater than 0 and I just decrement I. Again, I calculate the value of dx. Whenever this inequality is satisfied, I calculate the value of dx and I decrement the value of dx from v of I and v of I minus 1. So dx is the minimum value that I need to change to satisfy the correct ordering. At the end, what I can just do it, I can check whether the final vector is sorted. If it is sorted, the answer will be yes, otherwise the answer will be no. So this would be the solution of the third problem. And this is all for today's video. I hope you guys were able to understand the solution. If you guys did, then do consider dropping a like and don't forget to subscribe to this channel. It's always free of cost and you can always unsubscribe if you don't find the content interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.